Hey, this is Tyler Christopoli from SPEC, and we're going to talk about the Sgarbossa criteria for a little bit to help you identify an MI in the presence of a left bundle branch block or a ventricular paced rhythm. Now we know that we have always been taught that you can't identify an MI in a left bundle branch block or a ventricular paced rhythm, and that's because the axis deviation has kind of a false ST elevation that we see. So the Sgarbossa criteria came about to help us try to identify an MI in the presence of that left bundle branch block. So before we get started, we need to become familiar with two terms. One is concordant, and one is discordant. And all these terms refer to is where the complexes are in relationship to the isoelectric line. So concordant is our normal positive QRS, positive T wave that we see in our EKG. Discordant refers to more of the pattern that we see in a ventricular pace or left bundle branch block rhythm, where we have that inverted QRS and then we have the positive T wave. So keeping these two terms in mind, the Sgarbossa criteria says that, I'll erase these first, that if we have greater than 1 millimeter of concordant, that's a little more than 1 millimeter, but if we have greater than 1 millimeter of concordant elevation, that's the highest criteria for identifying an MI. Now the next one is discordant elevation. So if we have our QRS that's negative, and then we come up at 1, 2, 3, 4, 5. If we have greater than 5 millimeters of discordant elevation, that is the second highest criteria to identify an MI. So this is number one. If you have this is number two. And there's a point system. I believe concordant is worth 5 points and discordant is worth 3. So I'm going to get these out of the way because there is a third criteria. The third criteria has to do with depression. So if we have greater than 3 millimeters of discordant depression, that is the third criteria. And we'll draw out what that looks like. So we got our negative QRS complex, and then we're coming up, and we got that depression there. So if we see this is it's the third criteria. It's only worth 2 points. So those are the three criteria. So now let's look at an EKG and see if we can identify if a patient is having an MI. So we look at this EKG here and we can see the patient does have a left bundle branch block. If we look over in leads V5 and V6, we can see we have concordant elevation that's greater than 1 millimeter. So here's a criteria right here. This criteria is the number one criteria. And what do we say this was worth? I like to say I think it's 3 points. No, this one is 5 points. I'm sorry. Let me erase that. So here. And this one is worth 5 points. Now if we look over here at this one and this one, we can see we have the greater than 5 millimeters of discordant elevation. And this one is worth 3 points. So at a total of 8 points, I think it's safe to say that this patient is experiencing an MI. So we can kind of see how that plays out when we're interpreting the 12 leads. Now, the one thing we have to remember is the Sgarbossa criteria says that if we have greater than 5 millimeters of discordant elevation, which is the most common we will see with the axis deviation of a left bundle branch or ventricular paced rhythm, that it's an MI. Well, if we look at this picture up here, we can see we only have 3.5 millimeters of elevation here. But we got this long S wave. So the modified Sgarbossa criteria is going to help us identify more MIs. The normal Sgarbossa criteria has a specificity of approximately 98%, and it's 20% sensitive. With adding this modification in it that I'm about to show you, we increase that sensitivity to almost 95%. So what we do is we look at the amount of elevation that we have. So we'll say this is 3.5 millimeters, and that's going to go in our box. We're going to divide that by our S wave, which in this one the S wave is 10.5. And if the ratio between these two is greater than 25%, then we can activate and say that yes, that is a STEMI. So we'll divide this in here. We'll say we had to add a 0 here. And 10.5 by 0. This is 3. And that goes into 315. And we will, let's see, that comes to 5. This is 3. And we bring down another 0. So we're going to see we get 0.33 repeating. So this is greater than the 0.25%. So we can say that this patient is having an MI. And this is great too if we have a low voltage EKG. We got to remember it's more important to look at the relationship between your S wave and your ST elevation rather than the actual amount of elevation. We want to watch the ratio between the two, and that's going to help our sensitivity go up quite a bit when trying to identify an MI. I hope this was helpful. If you guys have any questions or comments, leave them in the box below. Thank you.
Made with Doodlecast Pro.